Forget the old flashcards, forget the rote memorization. What really goes on inside a modern math class today? Well, we're going to peel back the curtain and we're going to deconstruct a real lesson plan to show you the blueprint for how kids learn to think, not just, calculate.
Right, so what's the secret sauce here? How do you actually build a student who doesn't just spit back answers, but who genuinely understands the language of numbers? That is the big question we're going to tackle.
Well, the answer starts with this really fundamental shift. We're moving away from drilling multiplication tables until your eyes glaze over. Instead, modern teaching is this very deliberate journey. It takes a student from things they can physically touch and see to these really complex ideas they can hold right in their mind.
All right, so let's get into it. To really understand this blueprint, we first have to know what the goal is. What specifically is a lesson like this trying to achieve?
It really all boils down to two big ideas that are totally connected. On one side, you've got the foundation, understanding something called number bonds, which is basically seeing which pairs of numbers just naturally make 100. And on the other side, you have the strategy that this foundation unlocks, being able to quickly and just super efficiently add to the next 10.
Any good lesson has to start with a hook, right? Before you can get to all the theory, you have to make it relatable, something that actually connects to a kid's world.
And here's exactly how they do it. Instead of just throwing abstract numbers on a page, the lesson kicks off with something real, something tangible. Counting animals at a zoo or creatures in an aquarium. It immediately grounds the math in their world and, boom, you've got them engaged right from the start.
Okay, so once everyone's warmed up and engaged, it is time for the main event. Let's dig into the absolute heart of this method and see how these teachers build that deep, conceptual understanding one layer at a time.
First things first, we've got to understand the core concept here, number bonds. So what are they? Simply put, it's about seeing these hidden relationships between numbers. It's moving past just knowing that 7 plus 3 is 10 to instinctively seeing 7 and 3 as this natural pair that belongs to 10. It's about seeing the whole and its parts, all at the same time.
Now this part is absolutely crucial. Students aren't just thrown into a sea of equations. They follow this really clear three-step path. First, they start with the concrete. They're physically holding and moving around blocks. Then, they move to the pictorial. They learn to draw those blocks, maybe on an abacus or a number line. And only then, after they've touched it and they've seen it, do they move to the abstract symbols of a number sentence.
And wow, this slide is it's perfect. It captures that whole three-step journey in a single shot. You see, on the left, you've got that pictorial stage, the visuals of the abacus and the blocks. And on the right, you've got the abstract result, a clean, simple equation. The lesson plan makes sure to explicitly connect these two worlds, so those symbols on the right are always tied to something real.
So, okay, where are we going with all this? Mastering one little concept, like a number bond, that's not the end goal. It's actually the key that unlocks the ability to solve much bigger, way more complex problems, and with surprising ease.
It all starts right here, with a simple, foundational fact. You master that 6 and 4 are a bond. They make 10. You know it inside and out, backwards and forwards.
Then, and this is the cool part, the teacher helps you spot the pattern. See, if you already know that a 6 needs a 4 to make 10, your brain can instantly see that 16 needs that same 4 to get to the next friendly number, 20.
And this is where the magic happens. This shows you just how powerful this whole method is. Once you see that pattern, you haven't just learned to solve one problem. No way. You've unlocked the entire system. You can solve a ton of similar problems because you understand the underlying rule, not just one single answer. So let's put ourselves in a student's shoes for a second. Here's that logic in action, right from the lesson plan. A student is looking at 82 plus blank equals 90. Their internal monologue isn't panic, it's pure strategy. They think, okay, I know my bonds to 10. I know 2 and 8 are a pair. So it's got to be that the 82 also needs an 8 to get to the next 10. It's this beautiful logical leap. It's not a guess at all.
So the big question is, how do teachers even know if all this is sinking in? Well, the way we check for understanding has evolved too. It's becoming less about just a score on a test and way more about building self-awareness in the student themselves.
So, for example, a student might say, okay, I'm a trying turtle right now. Now, this is not a sign of failure. It's actually an honest self-assessment. It says, hey, I'm on the right path, I'm making progress, but I could still use a little more support. Or, maybe they feel like a learning lizard.
This student recognizes, okay, I'm at the beginning of this idea, and I'm totally ready for more practice to build up my confidence. It's all about knowing where you are on that journey.
And then you get the confident camel. And this is what mastery looks like. A student here doesn't just get it. They are so confident that they can actually turn around and explain the whole concept to a friend, which, let's be honest, is one of the deepest forms of learning there is.
And listen, this is so important. This whole system of camels and lizards and turtles, it's not about slapping labels on kids. It's about giving students a language to understand their own learning process. It empowers them to know when to ask for help, and just as importantly, when to offer it.
So when you step back and look at the whole picture, it's pretty profound, right? This systematic journey from the concrete to the abstract, and you combine that with this intense focus on student self-awareness, that is a powerful blueprint for learning. And it really makes you wonder, if it can demystify a subject like math, what other subjects could it completely transform?